Okay, there are questions for all of you, for Nick, Peter, and for Jannick. I will start with some questions for Nick. Nick, there are two questions to deal with air filtration. What is your approach to deal with pollen and particles in the fresh air? And the other question is it possible to install HEPA filters?
So for our natural ventilation systems, when we're having the system operating in natural vent, we don't have filters. When we're operating in heat recovery, we have a very coarse filter, and that's there to prevent the blockage of the heat exchanger core. And that works very similar to natural ventilation. Our terminals are very similar to openable windows. So, and that's the context we have. With our cool phase systems, they do include a filter. And again, we can incorporate fairly high levels of filtration because we have the mechanical fan included within the system.
Okay, thank you for your clear answer. The cool phase system, you showed us that you can simulate this with dynamic simulations in IES. Is it possible to have it in another software?
Yes, we've done several studies of modeling the phase change material in other dynamic simulation tools, and we've got some how-to guides that I can share on that.
Okay, thank you. And then about the wind catcher, I think, what is the maximum length of the Monodraught column before the air pressure is no longer capable of pushing the air downwards? Do you have an idea of this?
Yeah, so that's all dependent on size, and then you get to a balance point of the size of shaft compared to the ventilation performance. So roughly speaking, 3 floors of a chimney effect. You then go into a balance that if you've got low level openings, the system acts more in a chimney effect than it does on a top down ventilation, dependent on wind scenario. But again, dynamic simulation can model all of that, and it can take that into account on low level openings when they're utilized, as well as the wind effect on top down ventilation.
Okay, thank you, Nick. Then I move on to Peter. Peter has one question about the air quality. How does the system prevent outdoor air pollution from adversely impacting indoor air quality?
So yes, this system, I mean, basically the system I've shown here are a natural ventilation system, so there are no filtration included in the system.
Yes,
the houses have been included are based in say residential areas. The one in Brussels in a area called Bel Air, reflecting the air in the area. Yeah, basically there's no filtration, you could say, but the outdoor air has been reasonably well equipped for natural ventilation in these areas.
Yes, I agree with the natural ventilation system. Yeah, it's the outdoor air that you take in. So yes. Okay, thank you. Then I move on to Jannick. It's a question to think about. Yes, we mentioned before the Persian wind catcher, and they were combined with underground air tunnels to cool the air. So yes, and the question is, although most earth-to-air heat exchangers are fan-driven, the question is naturally driven earth-to-air heat exchanger, is it potential in a hybrid system? And what do you think about the limitations of such system?
Yeah, I think this is also a combination with Nick's presentation, I guess.
Yes,
with the wind catchers.
So yeah, with regards to wind catchers, yes, the Persian architecture utilized a lot of evaporative cooling, and I think that goes back to Peter's original conversation on evaporative cooling being incorporated within as a ventilative cooling option.
Mm-hmm. And if I may add, if I may add a good, I think they are still a very welcomed element of hybrid cooling, those earth-to-air heat exchangers. Yes, they can be driven naturally because you can dimension them at very low pressure drop still. And we made the experience that it could be a good idea to allow a kind of shortcut, because there are times when the earth tube heat exchanger is already warm, and then the temperature outside drops and you might have the benefit to have the air directly in your house because it's already cooler, and you might have the air from the already warm heat exchanger not being pulled in your house necessarily. It's quite the same situation like Peter Foldbjerg mentioned. When you have a staircase and the air gets warm in the staircase, you're happy if it is pulled out directly through the roof window and not pulled through your sleeping room. And so it's a good idea to have the earth tube heat exchanger equipped with a shortcut that discharges it without entering the house. So this was a learning from one of our projects.
Yeah, thank you, Peter. I think indeed that's one of the important aspects. Okay, I move on to the next question, and I think it goes to Peter Foldbjerg and Jannick Roth. It's about control and security. So the question is, how were the windows controlled to maintain both a good performance against overheating and security, and which windows and what control, is it automatically or not? And has the system worked as designed during occupancy?
I can answer to at least for the projects I presented. It's definitely a very important issue. For specifically one of the houses in the Model Home 2020 project, the one that was located in Germany, we had some ground floor bedrooms where we ran automatic ventilation during the night. Also, when the family moved in, they didn't feel comfortable and secure in that setting. So we changed the control so it didn't operate during the night, but did some thorough airings just before bedtime and in the morning. So that was the solution that we found there. But it's definitely clear that when opening, you could say, big facade windows, that comes to some people with an issue of compromising security or privacy. And for example, the house in Brussels, we used small top located openings in the larger window, so it was sectionized, and these windows are not compromising the feeling of, you could say, safety or burglary in the same way. So that's how we controlled it.
Okay, thank you. Jannick, is there something you will add here?
Yeah, it's almost the same as Peter. I think so. Of course, this is something we have to take in consideration in the design phase. So and also we can also combine these with Leuven's system and so on, right? So as shown earlier on. So I think in our project, at least those I've showed, we use the same, you can say, high level openings as small high level openings, which also Peter showed. So I think this is how we actually can, you can say, still open the windows during the night time without, you can say, compromise the you can say, burglary thing.
But then you're talking about automatic control.
Yeah, exactly. So we're not talking about it's purely automatic control, and by that we can also, you can say, we don't have to open the windows fully. We can of course have them at a smaller opening degree during the night time if someone is worried about the, you can say, that aspects, of course.
Okay, thank you. I will have a look if there are other questions, but I think we're almost out of questions and also out of time. Okay, then I think it just rests me to thank all the speakers for their interesting presentations and their practical view on resilient ventilative cooling. And I also want to thank Maria and Valerie for their valuable support. And also thank you for viewing and listening all over the world. And if you have just 1 minute left, please fill in the feedback so that we can continue with organizer webinars on, of course, other interesting topics. Okay, see you. Bye.